Hello again. Today we are going to solve equations and check for extraneous solutions. All right. So first, let's solve. So you'll notice here I have a log with no base. So that means it's log base 10. So they are the same base. Since this is addition, I can use the product property of logarithms. So that means that this becomes log of 10x times x minus 3 equals 2. And if you saw my last video, you'll know that you can exponentiate this and this with the same base. Now, since these here both have a base of 10, even though it's an invisible 10, I will make my base 10. So I'll say 10 raised to the log of 10x times x minus 3 is equal to 10 to the second power. Well, I can simplify this. I know that 10 to the second power is 100 because 10 times 10 is 100. I also know that because this log here has a base of 10, I'm raising 10 to the log base 10 power. That cancels, and I can just bring this down. So now I have 10x times x minus 3 equals 100. Now what I'm going to do is I'm going to do the distributive property, and I'm going to multiply this 10x by x, and then I'm going to multiply 10x times negative 3. So now I have 10x squared minus 30x equals 100. Well, I can subtract 100 on both sides. I'll bring that up here. And now I have 10x squared minus 30x minus 100 equals 0. Is there a common monomial I can factor out of these? There is. I can actually factor 10 out of all those terms. So I factor out 10, and I'm left with x squared minus 3x minus 10 equals 0. Now I can factor x squared minus 3x minus 10. So I have 10. I'm going to make my two parentheses equal to 0. I'll put an x in each one. And now because this here is minus, I know that I will have a plus and a minus in my parentheses. Now two numbers that multiply together to be negative 10, but add together to be negative 3 would be positive 2 and negative 5. Now I have two binomials that I can set equal to 0. You may be asking, what do I do with this 10? Well, if I divided both sides by 10, the 10 would just cancel. So, but I can set x plus 2 equal to 0 and x minus 5 equal to 0. Well, I subtract 2, x is equal to negative 2. And I'm going to add 5, and I'm going to add 5, and x is equal to positive 5. So now our solutions appear to be x equals negative 2 and x equals 5. But now is the time in which we check for extraneous solutions. Okay? So by this time in Algebra 2, you should have already learned about what extraneous solutions are. They are solutions to your problem that appear to be correct, but are not. So over here is where I'm going to check for extraneous solutions. So first, let's try x equals negative 2. So let's plug this into our original equation and see if it's true. So we have log of 10 times negative 2 plus the log of negative 2 minus 3 equals 2. Well, we have the log of negative 20 plus the log of negative 5 equals 2. Well, we have a problem. The problem is I can't raise 10 to any power that is going to give me a negative number. So 10 raised to any power equals negative 20. There's no exponent I could raise 10 to get a negative number. So if you ever have a situation where you're taking the log of a negative number or the log of a negative number, you would say that negative 2 is not a solution. That is an extraneous solution. But if I plug in log of 10 times 5 plus log of 5 minus 3 equals 2, well, that's the log of 50 plus the log of 2 equals 2. Well, that is log of 50 times 2 equals 2, so that the log of 100 equals 2. Now, here's the question. Is it true, if I put a 10 in there, is 10 to the second power 100? Yes, yes it is, because that's what this logarithmic equation means, is that 10 to the second power is equal to 100. That's how you would write that in exponential form. So that means that our answer is x equals 5. And that's how you solve these equations and then check for extraneous solutions.